Thank you. Okay, and notice I changed my betas to x's. And if you want to, you can change your betas to x's, or if they use the betas or the alphas and you want to change to x's, that's okay. Because sometimes, like in Alpha 2, not just a while ago in 5th block, they were using s's in the problem, and he ended up messing up the problem because he thought it was a 5. So sometimes it's easier just to go ahead and change it. Okay, let's see. Delaney, what would you want to start with? Just tell me
I
something.
would take tangent and make it sine over cosine plus cosine over sine, and I would just put the divide. I wouldn't like draw the line, I would just put the
You wouldn't even mess with this yet?
yeah.
Okay, that would probably be a good thing to do. Which I said, when you first start doing these, it's easier to change things to sine and cosines until you get used to doing it.
Yeah.
Okay? So now, what do you think we do with this one next? Zach, what would you do with this numerator on top?
Common denominator.
So my common denominator is,
Cosine, sin x.
so I could do the butterfly though, right?
Yeah.
Which, all that is a wing. Sine times sine is,
Sine squared.
cosine times cosine is, which the butterfly method is this wing times each other, this wing times each other, added together because it's addition, over the two numbers multiplied times each other. Okay, now Dalton, what do you see on that one?
The sine and the sine squared and the cosine squared can turn into 1.
That's what I would go to. Does everybody agree with that?
Mm-hmm.
So we have 1 over cosine sine is a numerator, and it's being divided by secant squared. Since I already have these in terms of sines and cosines, what could I do with secant squared?
Change it to 1 over cosine squared.
1 over cosine squared. And then what do you normally do when you divide?
Multiply by the reciprocal.
Right, so that means we want to multiply by cosine over 1. So Mason, what would we do?
Cosine. Did we change the secant squared to cosine squared plus 1?
We made secant squared 1 over cosine squared.
I mean.
And then we inverted it because we're dividing.
Mm-hmm.
And now we're down to that last step, Mason, what would you do on it?
Just multiply across.
And can we cancel as we go?
Yeah.
Well, one of those cosines cancel the cosine squared to a cosine?
Yeah.
So we're left with cosine over sine. Which, Tara, what is cosine over sine? Cotangent. So we've simplified it to a single trig. Again, can this be done a different way?
Yeah.
Yes, that's just the way, I usually like to have you guys help me do them, so I see different ways of doing them. Oh, 37 looks good. I'm curious to see how somebody will start me off on this one. Who wants to give me an idea of what to do first? Okay, what would you do?
Change the tangent to sine to the 4th over cosine.
That'll work. Oh, you said to the 4th, sorry. And you want to leave the bottom alone for now?
Yeah.
Does everybody agree to work with just the numerator?
Yep.
Now, what can we do in that numerator, White? What would you do?
I'd split them up, because they are different squares, but
That's what we could have done. We can go back to that if you want to do that. What could I do with this, though?
just get,
Butterfly?
yeah, just combine them.
So that's going to be what?
Sine.
Cosine to the 4th?
Yeah, minus sine to the 4th, over cosine.
Does everybody agree with that?
Yeah.
Now, if you wanted to, can't we still do the difference of squares?
Right, up top.
So everybody see on top, cosine of the fourth minus sine of the fourth, we can factor it? Okay, yes, Delaney?
Could we like cancel the two cosines for that? No? Okay.
Because you're in addition subtraction. I don't know if you've heard the story, but when you're married in math, you can't divorce.
Okay.
So if they're together, in addition or subtraction, they have to stay together unless you have something exactly like it to get rid of it. Okay,
it's
so
like a
we can't do
binomial?
that. Hmm?
So it's a binomial?
Yes, that's a binomial, but that we can factor, can't we? As a difference of two squares. What times what gives you cosine to the fourth? What times what gives you sine to the fourth? And I'm running sine squared, right? One's positive, one's negative, over cosine to the fourth. And it's being divided by this thing up here, right? And that's over 1. When you divide, what do? Invert and multiply. Now what happens? I see a lot happening. Richard, tell me something.
I'm still trying to find where I went with this.
You can cancel the,
Well, that's what I wanted Richard to say. Cosine squared minus sine squared.
I'm sorry, I was lost trying to write everything down.
Yeah, doesn't that cancel?
one.
Okay, now, let's see anything else? JC, what could you tell me about cosine squared plus sine squared? It's 1. That's that identity I said you're gonna be using a ton of. Did you find out you used it a lot in the exercises?
Yep.
So this is 1, so I've got 1 on top over cosine to the fourth, right?
So that'd be secant to the fourth?
That would be it. And that would be your answer. Okay? Another one. Now, you don't have to write all these down, I'm just giving you enough practice to see what we're doing. Oh, let's see,
How many do we need?
you're good. If you got a couple is all you need. I just want you to stay with me on notes, or doing them with me.
Can we do one of the long ones, like 45 or something?
Yeah.
Sweet.
Well, let's see. 45?
Sure.
So we know our answer should either be 0 or 1. Okay, now, if we want to change everything sines and cosines, could I do that all at first?
Yeah.
Since nothing's squared, I can't use any of the Pythagorean ones. Everybody agree with that?
Right.
So probably the best bet is to change to sines and cosines. So, Taylor, what's cosecant change to?
Cosecant is 1 over secant, or secant over 1.
Either way, 1 over sine,
1
right?
over sine, sorry.
Yeah. Secant changes to 1 over cosine. Is everybody with me there? I think we've got it written there. I could have written this the other way too. That might make it easier for you guys. Okay, now what's cotangent change to? And I think I wrote that down right, didn't I? Wasn't that a cosine? Okay, so, not gonna mess with this fraction yet. I wanna do this one first. Is everybody okay with me? Okay, the top is okay, but what could I do on the bottom? Common denominator, so the common denominator would be, so I need to multiply that by cosine? You guys agree with that? Or you could have done the butterfly. 1 changes to 1 over 1, so there's cosine plus 1 over cosine. So you get the same thing no matter which way you go. Now, what's this mean again? Divide. So that means you multiply by the reciprocal or you invert it, whichever way you'd rather call it. So I've got cosine over cosine x plus 1. Is everybody okay with that one to that?
Hold on. Are we gonna go ahead and multiply, or
We can,
Well, is it easier?
it doesn't matter.
Okay.
Like I said, there's, really doesn't matter the order you do things. So this is gonna be cosine over what, sine times cosine x plus 1. All I did was take 1 times cosine and then I left that factor because I see something that may help us later.
Cancellation.
I'm hoping, but we'll see. Now, what do we do here? Doesn't this again mean to do what? Doesn't this mean to divide? So this is over 1, right? So when you divide, you invert it or make it its reciprocal. So what do I get there? Multiply, right?
Cosine of x over sine of x times the quantity 1 plus cosine of x.
And,
Hold on.
okay, all we did right here, Dalton, is we inverted this. 1 plus cosine over 1 we inverted, so, because this meant to divide. So then you multiply cosine times 1 is cosine, and sine times that I just left in that format. Well, I could have said 1 plus cosine, but I already had the other one anyway. Okay, now, isn't this the same denominator?
Yep.
So since it's the same denominator, if I have 2/3 minus 2/3, don't you just subtract your numerators?
Yeah.
So in this case, what's cosine minus cosine?
0.
What's 0 over anything? The answer is 0. Okay, another example. Let's see. How did you guys do on number 32? Did you guys, 32, in the assignment that you handed in today?
I have difficulties with that one.
Would you like to see that one?
Sure.
I think of that one two different, I see right off the bat, I see 2 different ways I would do this one just by looking at it. And I gave a hint, is the way I think that's the fastest. Butterfly. Does everybody see that butterfly?
Yep.
Anytime you have addition or subtraction of fractions, you can do the butterfly. So this would become,
Tangent x plus 1 squared.
which I'm gonna write down twice, because what are you gonna have to do eventually?
Foil.
FOIL. Minus, what's this wing?
Secant squared.
Over secant times 1, which is secant. Now, what's tangent of x plus 1 times tangent of x plus 1? Foiling?
Tangent square of x plus 2 tangent of x plus 1.
Tangent plus
Yeah.
1 is secant squared.
Tangent squared plus 1 is
Secant squared.
secant squared, that's right. Does everybody agree with that statement? So, if I circle this with this, do you guys recognize that that's secant squared? Or I could write it together if it helps you. I'll put secant squared above it. You guys follow what I just did? I moved the 1 over with the tangent squared. And don't we know tangent squared plus 1 is secant squared? That's one of our identities. So what happens to the secant squared minus the secant squared? It goes to 0, so all we have left on top is 2 tangent. And it's over secant. What do we know tangent is? Sine over cosine. And we know secant is 1 over cosine, which when you divide, you invert and multiply. So what do we get? 2 sine.
What happened to our secant squared?
It's subtracted out. Secant squared minus secant squared.
Okay, gotcha.
Okay? Now, let's pick something from the one you're doing today. And then I'll let you guys have work time. So from 17 to 33, and 41, 43, which I think 41, 43 is not that bad. Yeah, I see butterfly on both of them if you wanted to. So which of those would you like to see? We'll pick one of them to do together.
Which ones?
any of the odd numbers, 17 through 33, and then 41 and 43.
Um,
31?
Sure.
Now this one I've done probably 5 different ways, but the one that's the fastest,
Butterfly.
no, is making use of this right here. What's another way of saying cosine squared? Remember I said these can be rewritten different ways? 1 minus sine squared? You guys agree that that's true?
Yeah.
I'm just doing it the fastest way. You could also do it by the butterfly method and it works too. What can 1 minus sine,
Was it, cosine squared?
cosine squared can become 1 minus sine
Oh,
squared?
okay, okay.
Okay? Now, what can I do with 1 minus sine squared? It's the difference of two squares, right? So can I factor that?
So what did you
1 minus sine,
1 plus
1 plus sine.
L1.
So now that cancels, doesn't it? So what do I have left? 1 minus sine. So that's 1 minus 1 plus sine when I distribute by the negative. So what do we end up with? Now, personally, that's the way I would have done it. But, didn't I say we could have done the butterfly too? Put this over 1. It would have been 1 plus sine minus cosine squared over 1 plus sine. And then you would have to change the cosine squared eventually to this, so that the sines you would be able to combine and factor. But this one's the fastest way. Okay, if you follow what we did there. Okay, now you can turn the camera off and then we'll... I want to see some of these to make sure you're going good. 17, 19, somewhere in that group.